afternoon, everybody. So, today we've got battery placement issues, and I was just about to try and solve them, but I figured I'd turn on the camera to kind of show some of the process that we're going through right now. So, last time we've been making PCB changes, and we're almost done. Like, I was hoping to have this off to the fab house like a week or something ago, and still haven't. But we're getting really close, and I'm thankful I didn't because I have found a major issue. Last episode, I showed you that we had the batteries that are in these big guys right here, 1800 milliamp hour. And let's get just right into it. Let's switch over here. Okay, so a couple of things. First of all, I got 10,000 of these from China, which is awesome. This is double-sided tape. This is the same kind of tape that you use to hold your phone batteries in. If you've ever taken apart your iPhone to replace the battery, it's the kind of tape that where you put it on and then you stretch it out, it releases, doesn't leave any residue or anything, and you're good to go. So I've got a whole bunch of these, and look how many I've used just doing some testing. So, all right. So here is our case, and what I was thinking of doing was just sticking the battery down in here like this, and then connecting it to the electronics, which rest in this side, and then clamshelling it together. And so what I did was I took one of these, put it in the bottom here, and then put the battery in. The problem with that is how incredibly difficult it is to get out. You're never getting it out. And the reason for that is if you've ever taken apart an iPhone or an Android or something and done the battery with this releasable tape, is the best angle to pull it is like a very slight angle, like a 30-degree angle from the surface to stretch it out. Should we do a demo real quick? Fine, let's do a demo. Demo time. All right, so I'm going to get a piece of this stuff, and I'm going to slap it on here. Doesn't have to be perfect, just any old place. Great. Put that on. So you do that, and then I actually just cut my fingernails. It's pretty hard to get the release paper off without a point. Okay. And we pull that off like that. And then we stick the battery on. So this poor battery has been through enough. Let's use this battery. So we take a battery, and before the orientation doesn't matter, but let's just say we stuck the battery on like that. Give it a real. You don't even have to push it very hard, and it's on there. It's not coming off. Like, you can shake this thing all day long. It's not going anywhere. You want to try and pry it off, you're not prying it off. In fact, when you do try to pry it off, you start to get this, like you start peeling the battery. Like, you can see how I kind of damaged this battery here from trying to pull it off. It's not coming off. It's on there very firmly. And the way you get this off, which I'm probably going to need my tweezers for, if you have access, you just kind of get down in here, and if you can get it started a little bit here, all you need is a very small piece of it to get moving. Almost, and it'll start to stretch like you've never seen. But it rips really easily because it's so thin. Yeah, I just ripped some of it off there. So with the board in my hand like this, you can see how it's kind of an issue. Now imagine the tape is down in here. There's no way you're getting your fingers down in there to pull it out at an angle. And so let's just camera nerves here. Trying to get this started. You're just going to have to bear with me because we're doing this. Okay, there it goes. You see how it's starting to stretch like that? You just, oh, I lost it. Oh, come on. Let's grab it. And then I get it like that, and I'm going to start to pull it. You'll see it start to stretch, like crazy stretch. So it just kind of makes a satisfying sound too. You just kind of keep grabbing it closer and closer and just kind of pulling it at an angle there. And it just stretches and stretches and stretches. You see how that's not even halfway yet. It gets this straight, crazy stretch. You want to keep it moving. Like that. And ta-da, the battery's released. You just pull the rest of it off there. See, like that. And once you're done with that, there is no residue on the battery. There is no residue on this. The tape is pretty fancy. And so very strong hold and easy to remove. Now, what you might be asking is, why do I care? Why don't I just stick a piece of it down in here, slap the battery down in there, call it a day? It's never going to go anywhere. Well, something that's near and dear to my heart, and I mentioned earlier, if you've ever repaired an iPhone, this is becoming increasingly difficult because companies don't want you to be able to work on your devices. They don't even want authorized third parties to work on their devices. They want to lock you out of them. And I hate that. I'm a huge believer in right to repair. And I want to be able, if we need to change a battery in one of these, or even have a customer change the battery, that they can do that. And I'd be happy to sell you a replacement battery and a piece of this fancy adhesive to put it back on the way you got it. And so I didn't like that if we put the adhesive down in here, it's never coming out. Like, you're not going to get it back out. And the reason I know that is because I tested it, and this is all part of the process of going through this. This is all that is left of the test enclosure that I tested this in. Because I couldn't get the battery out, so I ultimately just destroyed it. Cut it open with some pliers. This is all that's left of it. The rest of it's in the garbage, and keep this as a little keepsake. Just to change the battery. And that sucks. I don't want to be that guy or that company. I want these things to be repairable and serviceable should they need it. And not just from a perspective of being a huge right to repair advocate, because I am, but also, if somebody needs, I don't want to just, planned obsolescence is not something I'm interested in at all. I want these to work for as long as you care to have it as a owner of the product. And I think it's dumb to have to destroy the entire case and throw it in a landfill just to get the battery out. Even if I did say, well, just crack it open and ruin it and get the electronics out and throw everything else away and we'll give you a new case, that sucks too. So anyway, that's the maybe longer version of the story than you wanted, of why I can't just put the battery down in here with some adhesive, because it's never coming out, and I don't like that. I want these to be repairable and serviceable. So that led to our next problem, which I will show here. Let me put my tweezers away. The next problem is new battery right here. And let's get an old version of the hardware, which different main chip and things like that, but the location of the battery female end is in the same spot. As you can see, if I put them side by side, it's just on this side of the board. Well, here's the old battery. And what we did was we put it on like this. And as you can see there, right on facing the camera, we've got room on all four edges. It's snugged up tight against this connector. And then we would just plug it in like that. Well, the new battery is double the capacity, and while it is thicker, it's also longer. So if I snug this up there now, I overhang. You can see that. If I flip it over, you'll see I overhang quite a bit, which wouldn't be a huge problem if the case wasn't designed perfectly to these dimensions. And so if I tried to install this battery the same way, it's just not going to fit. Now, if I come up over here to make it fit, well, now I can't plug it in. And so what I'm looking to do is attach the battery to the back, because I have a blank one here. The battery fits without overlapping. Hold it like that. Looks good on all sides. But now, where do I put the plug for the battery? And I have spent, when I tell you, hours looking at this and trying to figure out how to solve this problem. I've got a battery now that's much bigger. I didn't realize how much longer it was. I only made sure that it would fit into here, which it does easily. You can see, we got all kinds of room. in there. But I don't want to mount it there. I don't want to have it, you know, you could just pop it in there and have it be free moving. I don't want to do that either. And as another argument against just taping it in here is if somebody ever did try to get it out and replace it, they are going to damage the battery, possibly explosively. Like, I almost went through this with my pair of tweezers. I started scratching the surface. It's not going to focus. I started scratching the surface of the protective coating here because trying to get my tweezers underneath of it until I decided just to smash the whole thing apart. But so how do we solve this problem? Well, let's take a look at our design here. So this is what I've been working on. I spent hours yesterday looking at different options. Before, if we zoom in, the J2 here, which is on the bottom side, was right here in this area. And on the bottom, not on the top. And what I looked at doing yesterday was putting it on the top of the board facing this way. And so instead of, let's switch cameras again. Instead of having it, so the way that you're looking at that in TinkerCAD is like this, and then it's just on the underside right here. I was looking at taking it from here, putting it on the top, get my fancy pointer here, putting it right here, facing this way, and then somehow like winding the cord up over the side, plugging it in, and then having the battery sit, you know, basically on the middle of the board underneath, and then the connector would be on top. The problem I came up with there, this led to another problem. So that was the solution. All we had to do was switch sides. We didn't have to do any sort of redesign on the board. No big deal. The problem then became, if we look at this, and we put that in there, there is no room to get the cable up and around. Like, that is just enough room for the lip of the other side of the clamshell to close together. So the spacing on this is like perfect to the enclosure. I don't have room to snake it around the edge, so I would need to notch the board in some way. But then I started thinking about how notching it and assembling it and making sure that the wires rest in the notch, like all of these things that I'm thinking through of, like, when I have to assemble or somebody else has to assemble 1,000 of these, like, that is prone to error. And if you haven't any issue with like that getting pinched in the case or between the PCB and the surrounding case and, you know, shaving the wire somehow or cutting through it, like, we have a big problem, like if we short those. So it's not something I want to mess with. So where I landed, I think, and this is what we're going to test this idea in just a minute, is I looked at this last night. As you can see, I've used a lot of these adhesive things so far, fixing the battery in different portions of the board. So where we ended up was, we take this and we mount the battery like this, and we pull it all the way over to the side. And if we do that, I'm going to turn this, I've got room right along in here to mount the connector right here facing this way. And then what I would do is I would just snake this around. I can actually use my tweezers again. What we would do is we would snake this around and plug it in right there. Hopefully the lighting's all right with that. And so I've got room to do that. And as long as I'm snugged up against this side of the board, so instead of being centered like that, get the angle right, I'm going to pull the battery all the way up like that, which gives me all this real estate over here to be able to put our connector. And that way I can use the adhesive to hold it to the board, which makes the battery serviceable and removable. And I can still keep the connector on the back side. It's going to be very tight. And I did that, but then I started to worry, because let's take a look at the KeyCAD here. So let's zoom way in. Now, so here's the new connector. The magenta color means it's on the back side of the board, so it's fine that it overlaps all these other pads and things because it's on the back side. Look how close we are to this edge of the board right here. If you can see that. I'm not sure why that. Oh, there, it fixed. It was just kind of a display issue. Okay. It's really close to the notch for the standoff. And that's okay. It can be there. But when I looked at the case, switch views again. And I'm not sure how well this is going to show up. Okay, yeah, there's the angle that we need. So here are the standoffs right here. 1, 2, and then 3 and 4. Right next to the standoffs are these little supports. And that's what gives the standoff a lot of strength. But it also, if we look, it's not going to zoom quite right. Right here, you can see off the side of it, there's a little lip on those triangular supports, which is what the PCB rests on. The other one's right there. And if we look at it straight on, this one's probably the better one to look at. It comes off at an angle like this. It doesn't come straight out. It comes off at an angle. And so if we translate that back over here, the standoff starts somewhere right around here and comes out this way at an angle. And if I just do that motion, what do you see potentially happening? We've got this pin right here that might be really, really close to where that triangular support comes through. And this is the type of thing where when you're paying whatever, 100 or 150 or whatever, excuse me, $150, let's say, to have these boards, have 5 of them made up. That's what we're going to do. We're going to do a run of 5 to test them. To get it here and then find out that this one pin right here won't let the board sit correctly because it's banging into a standoff support. Like, that would really, really suck. And so the next thought I had was, no big deal. Like, I know the standoff comes out through here. It's going to be really close if it's a problem at all. Let's just slide the connector down. Like, I've got a little bit more room, not a lot of room, because this yellow pad right here goes through the board. So I can't run it over. I can't run it over these pads down here. So I can only move it down so far without having to make other changes, like moving these resistors that are right in this area here. And so the other problem, so it's like, well, just move it as far as I can. The other problem that I run into is, we're back to overhead view. This amount of space right here is just barely enough space for me to put the connector there. So if I slide the connector down this way, like toward the battery, like I can't keep sliding it toward the middle because I need all the space out towards the edge that I can get. And in fact, I would shove it more up, but again, I'm worried about that standoff. Now, the way that I've been trying to look at this and solve this is super dumb, and so I'm saying this to maybe save you some time in your project, which is I've been using this little ruler with the millimeter side. You can use, I have calipers as well, to try and measure like how big is the standoff here and how far from the edge is it and how much room do I have on my battery to the edge and all this stuff. And then I realized it's 2021 and we've got so many great tools. And so what we're going to try and do right now as part of the stream is get a definitive yes or no, is this going to work? And so I'm going to change my view back over here to KiCad. One of the things that KiCad has, which is really cool, is if we come up here and we say view, 3D viewer, check this out. There it is. There's my board, like fully populated. We're not going to populate this header for the product. This would be there for anybody that wanted to use it as a dev board. Same thing for the buttons. Buttons don't need to be there for the product or this header, but this is a full 2-scale exact rendering. It even has the right PCB thickness of what the board will look like. And so as you can see right here, I can validate, if I zoom in, Because another thing I was worried about is how close are these pins going to be to this header if it's installed? And you see I've got some clearance there, so I'm okay on that. But what I can do is we can export this from KiCad as a 3D file and then take the 3D file of our case, push them together, and see how we look. Now, I'm not a professional CAD person, and so you're going to see my like cheat way of doing this, and hopefully it'll give us the answers that we need. So basically, we want to see oh my goodness. Oh yeah, no, we're okay. I was just thinking I might have a side issue. It lays in the case. It'll lay in the case like this. So that's what it'll look like in the case. The other thing I can do is 3D up a battery and see how everything looks and fits. So there's no, like, you can measure all this stuff, but if we have the tools and we know that everything should be exact, let's use the tools and actually visualize it instead of trying to picture it in our mind. And so I've already exported it. And to do that, just for those that are, maybe following along and trying to learn this for themselves, you just come up here to File, Fabrication, sorry, not Fabrication, Export, and I just selected step file because that's what I know I can import in. I believe I can import step files in TinkerCAD. If not, we can convert it. But you can just export it from here, and then you have it. And so I am just going to use TinkerCAD. You can use whatever CAD program you fancy. Like, doesn't matter which. And I'm just going to import them. So the first thing I'm going to do, let's see, STL. Okay, so it will not take a step file. No problem. What we're going to do is, I'm on Linux, and this is cross-platform. It's open source. Let me just drag it as soon as it opens. FreeCAD. And I could probably do all of this in FreeCAD, but it's not so user-friendly, and I haven't gone through the learning curve yet. So just in FreeCAD, it's free and open source software. I'll just do open. And we'll come into, where did I save it? Stat feeder hardware, right here. Stat feeder board step, just open that. And there it is. Now, it doesn't have things like the display connector because I don't have a 3D model for that. It doesn't have the micro USB connector because I don't have a model imported for that. But everything else is in here. Does it have, oh, it has like every single part that I could, oh, that's really cool. Okay, anyway, it doesn't matter. All I want to do here is now say File, Export, and what did I say TinkerCAD wanted? STL? Yeah, STL. Okay. You can just say File, Export as stat feeder board.stl. Save. Okay, great. We're done with FreeCAD. Now we can choose stat feeder hardware, stat feeder board.stl, and import. And it'll do its thing for a second. And apparently we're way zoomed out. That is so awesome. I know what just happened. Do you see that? Like, that is a single resistor. Okay, let's delete that. Let's open up FreeCAD again. I make this mistake every single time I'm in FreeCAD. Where did FreeCAD go? Here it is. File, recent. Let's open the step. What happens is if you don't select everything, and so what I had done is I had opened this and I selected one thing, and then I exported that, and it was probably, it might have even been this specific resistor, but we will select the whole thing, and then I think now if we do File, Export, and replace, I won't close FreeCAD this time. Let's be patient. I should have paid more attention to the dimensions. It probably would have given me a a hint that I was only importing a single resistor. And yeah, there we go. Let's zoom out. That looks much better. Okay, so now, again, the big thing that we are interested in is these guys right here when it goes into the enclosure. And so how do we do that? Well, we need the enclosure. We'll zoom out. And let's just put this up here. And I don't remember where the enclosure is. So that might take me a second. January 31st. This is probably... Let's try this, part 2 too. That looks right. Yeah, and this is actually, I don't need to import both sides of it. I only need to import this side. So what we're gonna do is we're gonna grab this and we're gonna rotate it 90 degrees so it's flat. There's probably like a control way to do this, but okay. And then we can also like lower it like to the work. Oh, there you go. On the over here to tell you how high it is off the surface. So TinkerCAD just has a lot of really nice things built into it like that. Easier for me to navigate anyway. Okay, so now this you'll be able to see a lot better. Let's do the top view. And then let's zoom in some. Okay, now this is what I was trying to show you in the camera earlier, how these come off at an angle. And that's what they look like from the side. The PCB rests right on here. In the front case, it's right on here. And what I had actually tried last night is if you look really close in here, this wall sits much lower. Let me move it up here. This wall sits much lower than this wall, low enough that I could probably snake the cable up through here, through this little area right here, over on top of the board. But again, as I played with that and I put the battery in place and used the adhesive and stuff, like, it's still just not a great manufacturing process. And again, I want to be able to handle larger volume. You know, hopefully that's necessary, but we just need to see if that's going to work for us. So, and I felt like that wouldn't for anything beyond a couple of hundred units. Like, it's too error prone, I guess is what I'm trying to say. So now what we want to see, and what I'm worried about, is now that we want to put the, let's get into a gooder view. I almost said that. With the PCB laid down right here, are those pins going to hit this? And this will tell us exactly, like, this is exactly the dimensions of the case. And we have our perfect dimensions of our board. And now all we need to do is, I should have left this off, darn it, when I exported it, because it will not be there in real life. Okay, so let's turn this around because it'll be installed like that. And it's actually going to be, go 180. It goes in like that. Yes. And so is that right? It would be on the way it goes in, it would be on the bottom side. Yeah. Okay. Okay. And so now what we need to figure is, let's lift this up. That thing's going to be in the way, I can already tell you. Let's line this up. Oh, that's not what I wanted to do. Something like that. That looks to be about lined up. Right there and right there. Now let's land it. It's probably off. Yep, it is off. Okay, that's okay. All we need to do, again, CAD is not my strong suit. That looks to be more aligned. Close. Not sure how like fine grain this is gonna let us get. We need to go over just a real small hair. So how do we do like very fine grain? Or is that even possible? Oh, snap grid is 1 millimeter. There we go. Let's take it down to 0.1 millimeter. Aha, I bet that'll do it. Yeah, now it's getting real fine grain. Okay. Look at that. Come over here. That one looks pretty good. That looks pretty good. Okay, now let's take a look. Okay, right now, that's the angle we're looking at. You see this right here? How close in can we get? Whoa, 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 whoa. To see, remember, we're trying to see if this leg right here is hitting this, and it does not look like it. Oh, here, this is the angle that we need right here. All right, it looks like we should be okay. We've got some clearance there. So I think we're okay. Again, this would drop. Well, let's drop it all the way down because right now it's not dropped all the way down. So let's take this and drop it almost right there. So, and in real life, this is how it works. It's flush. Like the standoff right here is flush with the board. Oh, man. Why didn't I start with this? Like, why was I even messing with the ruler ever? Let's see how it looks over here. Like, and it's so fun to see how, like, perfect the fit is. That's really cool. It seems a little tight on that side. So it actually might need to, yeah, it needs to come over a little bit. So we might not be out of the woods yet. Okay. No. Let's err on the side of caution and just bring it over another notch like that. So now there's like no gap on this side, and there's a little gap on that side. We're really close. I mean, we're talking tenths of a millimeter. All right, let's come back down into the money view. If I can get back into the money view, there it is. Like zoom through the wall. It looks like we're still okay. To be 100% sure, I'll tell you what we need to do. We need to come back in here to FreeCAD. Select this thing, whatever it is. Oh man, there we go. Can I just delete that? Aha! Because that will not be on the finished. Okay. File. Export. Oh, see, you got to select the file you want to export, or the objects. And let's do it as stat fader board STL again. Yes, replace it. Dev computer hardware. So this will be the version that does not have the header. That's what we just did. I went through that a little fast, sorry. See how it doesn't have, ooh, it no longer has the header across the top here, which is perfect. So let's zoom out so it's not so hard to deal with. Flip it over and flip it around and get it up off the floor. Great. And then let's dump this one and use this one instead. Okay, now bear with me. We have to go through this whole alignment process again. We should be faster at it this time. Oh, we're way off. We need to come this way. Something like that. All right. And then let's slam it down. Oh, man. That came together like a lot faster than I was thinking. Let's slam it down just a 0.1 millimeter. Yeah, I guess these do stick up just a hair. All right. And we're actually a little bit far over. You can see there. So let's inch it that way. But I'd rather err on the side of it being too snugged up this way than over here, because that's what's going to get us into trouble. Okay. There's our board laying in the case. Really fun. Okay, now let's go in for the zoom shot again. There we go. It looks like we clear that. Okay, so again, if you're just joining, I was worried about these pins right here, not this pin specifically hitting this standoff support, and it looks like we are just fine there. We shouldn't have any. I think there's even like a ruler, like, oh no, the ruler is really hard to use. Oh, whoa. What are we doing here? I don't know what's happening. There we go. All right. So I think we're good. And then just for like a sanity check, you can see like when the board's in, the standoff sticks off on the side a little bit. I'm just going to look at the in real life version of all this and see if that actually holds true. Ever so slightly. And I guess that's kind of what we're seeing is like ever so slightly. Yeah. Okay. So, you know, that passes the sanity check. Just because the CAD tells you it'll work doesn't necessarily mean it will. Okay. And another thing is I'm not going to hit. I mean, here's another thing to worry about is the standoff support structure here is not going to hit that. So, all right, last time, I just want to see it one more time. Whoa. You got to be at a certain, that's not letting me back in. But, I mean, we can see it there. Probably making you sick if you're watching along. See, like before, it let me zoom inside, but now it's not. That's as far in as it'll let me zoom. Let me inside. All right. But anyway, we're not hitting this support, so we should be okay there. Okay. Good. And then like the very final sanity check, like, and that's probably boring to watch, but like looking at this at every angle and making sure you haven't missed anything, super important, because again, free to fix it now. I mean, it's costing me time and you time if you're watching. It's very expensive to fix later when we get boards in and find out crap. Things bump in and it doesn't seat right. Like, so they say measure twice, cut once. In this, measure 50 times, fab and assemble once. And even then you'll be lucky. So the final check I want to do is like the hole lines up on site with the, almost the middle of the board edge here. Like if we drew a straight line out, we go right through the middle there. That makes sense. So let's come back in. And so coming off of here, if we go straight out, you can see like we're just about in the middle of the pin. So that all checks out as well. I think we're good. Like this is what I was trying to do last night with a ruler, like a clear ruler with millimeter measurements on it. So, all free tools. Like I have no expensive software that I'm using here. TinkerCAD is free to sign up for. FreeCAD is free software that runs on Windows, Linux, and Mac. So you have all the tools. All the tools are at your disposal. And I think we're a go with where we've decided to move our thing. Oh, now, last thing. While we're here in TinkerCAD, back to my measure 50 thing, let's get our battery. Sorry, I'm off screen here, but I'm going to open up the data sheet for the battery. I believe it has dimensions. .34 by 50. Let me just test that with my ruler. 50. 34 actually seems a little generous. L1 40. Oh, that's the bump. Okay, I'm not worried about that. I don't know what this N stuff is. I guess it's those things. So full length though. Yeah, 50. Okay. So we're talking 50 by 34, and it doesn't matter how thick it is because I have got room for days in the back side of the case department. So we'll do I don't know what the difference is between this box and this box. And I swear there was a way to like enter the numbers. Where you didn't have to just like drag it. Oh, you know what? I do remember now. You just click on them. Okay, so length, what did I say? 50? And width is 34. Oh, I lost it. How do I get it back? Oh, come on. 50. There we go. 34. And then the height of it. Oh, it's coming up from, oh, that's off the ground. No. Let's turn the snap grid back to 1 millimeter. Height. I want to change the height. How do I do? Oh, it's this one right here. There we go. Click on that. The thickness of it is like 10. Okay, so now obviously the battery isn't a perfect square. It's got some features to it, but that is the size of the battery that I'm using. And so now what we can do is, I don't like that being on the bottom, so let's flip this 180 degrees. Oh, it's still on the bottom. Okay, that did absolutely nothing. Great. And let's slide it over into place here. So this is our battery. Oh, wow, it's almost where we want it. Drop it down there. That's close enough. Like, it doesn't have to actually... Well, we can make it. Let's make it rest on the board. There we go. Maybe even overlaps a little bit. Okay. And now what we want to do is basically see how far we can get it. Okay, like that. Okay, so right there you can see I've got a hallway there. So the battery's good there. I've got some space there. Swing around to the other side of the yard here. Oh, I am awful at navigating this. I've got room here. The question is do I have room over here? It looks like maybe not. Oh, yeah, and this is about what I've experienced actually. So, again, these aren't perfect rectangular boxes. Like the battery kind of curls up at the edge here, and so it won't actually overhang. But you can see I've got room here as well. So that's my battery. I've got room for my plug right there. The cord comes off the top here. It'll wind around and just plug directly in right there. This makes me feel a lot like, it makes me feel better. It was working out in my mind with my ruler and my math, but like seeing it like this makes me feel better. And again, how well we're overhanging a little bit here, but that's not a big deal because we can do that because we had room on the other side. So now we're completely within, and again, it's not this perfect sharp edge. We're completely within that corner. We are completely within this corner. We're still on the board, and we still have that space right there. Okay. I mean, this is tight. Like, it doesn't get much tighter than that. I mean, that is an extremely, let's zoom out a little bit more. That is just really a tight fit, but it's going to work, I think. Like, I'm ready to move forward at this point and test this approach. And that way I can have my battery taped into place. Kind of the overhead view of it. And we should be good. The only concern now I have, see, new concern, is the newest, this is not the newest design. Jeez, I got to bring in the newest design. The newest design has a nub coming off of this to grab a hold of the board. Like, this is the fully concealed. That does poke through some. Love that. The concealed snap has a new part added to the back that comes off, which is what's going to hold the board into place. So if that protrudes more, no, the battery bends. We're going to be totally fine. I'm looking at this through the view of the battery having this perfectly straight wall over here. The battery is in a bend over here, so you've got actually quite a bit of room for it to snap into place. I think we're going to be just fine on that. Okay. But again, all these things you got to be paying attention to. And again, same thing over here. There'll be a snap. Do I have the new board? Stand by. Let's see if we can find the new board. They sent it to me. RYD. I've had a pretty good experience with RYD. Oh, he just sent a picture of it. I gotta find it. I don't know where that's gonna open up over here. I'm gonna pull that off. They didn't send me the updated 3D design, but I will show you what they added. Okay. Right here, they added these as a... Oh, sorry, that's my phone. Okay. They added these nubs right here, which will hold the board down in place. Let's see, it's about midway. Is that about what we're looking at here? Yeah, that does look about right. Midway up. That one's to hold that down into place. It'll be right here. Okay. All right, well, there's only so much measuring you can do before we just got to pull the trigger and see how it all works and comes together. If we need to make some minor tweaks, I think we've done as much measuring and confirming as we can do for now. So great. That brings us back to this. I think we're about ready to submit. In fact, I don't know that there's anything else left to do. If we just fill all the zones, save it, and then run the DRC. No problems, no unconnected items. So we're good. We've got everything in place that we need to. If we turn off the front, back copper looks good. Okay. All right, I think, were there any other changes I made to this that I wanted to talk about? No, there weren't. So I just, again, move that, test, measure everything, make sure everything's in place where we want it. And now what I will do is I'm going to do a separate stream submitting the order to PCB Way, which is who I use to have these things fabbed and assembled. And so we'll do that in the next video, which, yeah, we'll do that next time. I'm gonna close this stream off to chunk off a YouTube video, and then I might just start the stream right back up and do. I know there's other ways to do that, but that's an easy way to do it, to create 2 YouTube videos. To show you how we'll submit this order to PCB Way and get it all ready to get sent back to us so we can start testing. So anything else that I wanted to mention about all this? It's coming together. We're getting there. Once we have the hardware in hand, I sent off the order. The injection molded enclosure is underway. I mentioned that in the last video. So we'll have that coming in probably end of April. That's a big turnaround. We should be getting the boards back right around that same time, depending on supply of components. We will have everything we need to assemble a puck holder. So we have displays, batteries, adhesive to hold the battery to the back of the PCB. We'll have all the PCB assembly clamshelled together in our enclosure, and that'll be exciting. Getting to hardware complete is really fun, because then you don't have to mess around with all these measurements and things like that. You start to have to mess around with the intricacies of writing firmware and backend software, and I'm about ready to make that switch. Like, we've been spending a lot of time on the hardware design side here. It's about time for us to switch over and start writing some firmware. So next up, sending this off to PCB Way to be ordered, and then firmware. We'll be right into firmware after that. So we can have some code to run on these things when we get them. So that's going to do it for today. I appreciate everybody that's watching. And again, as always, if you have any questions about any of this, I'm happy to try and answer them. As you can probably very much tell, I'm learning as I go. I do have some experience and knowledge in these areas, but I would not in any way, shape, or form claim that I'm an expert, but I'm happy to try and engage and help other people and answer questions as best as I know how. So thanks again for joining. I hope everybody has an amazing day, and we will see you next time.